In this video, we're going to be talking about Chapter 4, Elements and Symbols, as well as the periodic table, atomic structure in terms of electrons, protons, and the arrangement of electrons. So the topics we're going to be covering, at least in this video, partially, is the first two topics, which is element symbols and the periodic table. The other topics are atom, atomic number, mass number, how to define that, how do you obtain the atomic number and mass number looking at the periodic table, and then what are isotopes, what is atomic mass, and then the subatomic structure or the arrangement of these electrons within the atom, and then specific periodic properties, the trends in those periodic properties like atomic size and ionization energy. So some of the skills that chemistry and math skills that will carry over are, again, positive, negative numbers, percentages, rules of rounding off, usage of the sig figs in calculations. So elements, as we learned before, are pure substances. So matter is classified into pure substances and mixtures. Elements and compounds are part of the pure substances. And so previously they used to think that that's as far as you can go in terms of breaking down of a substance or matter, right? You get down to the level of the element and it cannot be broken down any further. They were the building blocks of all matter. However, now we can break down an element, we can get to the atomic level and now further down into the subatomic level, all right? If you look at your book, your textbook, the front cover, the inside front cover has the periodic table, and right next to it, the page next to it has got the listing of all of the elements and their symbols. Okay, so one of the goals here is to make sure to learn the names of the elements and their corresponding symbol. So the names of these elements are derived from either the locations where they're found or named after famous people like Curium, named after the Curies, or planets like uranium, for the planet Uranus, mythological figures like titanium for Titans, or minerals from which they are derived, magnesium from the mineral magnesia, locations from where they are mined or formed, all right. Californium, for example, was actually created in the laboratory, the Lawrence Berkeley lab at University of Berkeley in California. And then you have chlorine and iodine. Chlorine has this greenish yellow color to it, and so they're derived from their Greek names, from the Greek words symbolizing their colors. So they occur in nature as greenish yellow gas, and iodine is a purple solid at room temperature. So the symbols of these elements are the abbreviation, or the symbols of these elements are either one or two letter words, rather two letter symbols, and they're derived from their name. So carbon, the first letter is C, so capital C is the one letter symbol for carbon. All right. So some of them have one letter symbols and others have two letter symbols. So carbon, nitrogen, fluorine, oxygen, they all have one letter symbols. Now, if there's a second letter, that's in lowercase. So the first letter is always in uppercase, and then if there's a second letter, that's in lowercase. All right. And so here you have magnesium, which is Mg. All right. One of the mistakes I do find students making is either writing both in lowercase or writing both in uppercase. So make sure that the first letter is in uppercase and the second letter in the symbol will be in lowercase. All right, so here are a partial listing of some of the elements and their names, and a few of them, as you can see here: gold and iron, lead, tin, potassium, sodium, and copper. They have names that are derived from their Latin names, not their present names. All right. So, not their present English names, but rather their Latin names, because these were elements that were discovered way back, all right, when Latin was the language that was commonly spoken. And then other elements, of course, you can see it's directly from their name. All right. And some of them also have been derived from their Greek names, like we looked at chlorine and iodine. Right. So some of them have names that are coming from their original Latin names. All right. So in this study check, it says write the correct chemical symbols for each of the following. Iodine is I, iron is Fe from ferrum, magnesium is Mg, zinc is Zn, and nitrogen is N. Give the names of the elements with the following symbols. So P is phosphorus, Al is aluminum, Mn is manganese, H is hydrogen, and K is potassium, from the Latin word kalium. So, the toxicity of mercury. This is just a chemistry linked to health. Long-term exposure to mercury can cause organ damage, especially to the brain and kidneys, mental retardation, and deformity or a decrease in physical development. Mercury toxicity can come from either ingestion of mercury from food or water, like food like fish, etc., or the industrial wastes in the water getting into the water. It's a liquid at room temperature, and then some of the ways that it can enter the body is again through consumption of food and water, or through the inhalation of the vapors. Mercury used to be used in thermometers, but not anymore. It's not even kept in the lab because of its high toxicity. So the main sources of this contamination are industrial waste, and as I said, fish and seafood, bulbs, and so on. Okay. All right. So here is the periodic table, and as you can see here, a large portion of the periodic table has this blue color. Now that's metals, all right? So a large portion of the periodic table, the left side of the periodic table, are metals. And then, so out of the 118 elements, a majority of those elements are metals. And then you have the non-metals on the right side. They are yellow. And hydrogen is a non-metal, but it's being placed here on the left side, and there's a reason for that, and we'll come to that a little bit later on. And then we have the 8 metalloids. There should be a ninth one, but literally a lot of these elements really don't exist, especially the ones down here, don't exist in nature because they're very unstable. So they exist for only fleeting moments. Some of them have been artificially created radioactively, and so they are unstable. Okay. So you have the 8 metalloids: the boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. Okay. Now, metalloids have properties that are kind of in between metals and non-metals. Okay, so they're called as metalloids. So typically, metals, we associate them with being solids and shiny, and you can hammer them and shape them and so on. Okay, non-metals tend to be mostly gases or powders like sulfur, not a regular shape, or liquids at room temperature. And then the other thing you will notice here is that um, the elements have been organized into columns and rows. So those columns are called as groups, and the rows are called as periods. All right. So you have 2 elements in that first period, and then you have 8 and another 8 elements in the second and the third period. And then you have 18 elements in the fourth period, and another 18 element in the fourth period. But here in the sixth period, you have elements between 50, it suddenly jumps from 57 lanthanum to hafnium at 72. So you have these 14 elements that fit in here from 58 to 71. They're called as the lanthanides, all right? So they go in here. And then the other 14 down here called as the actinides, and they fit in here between actinium and ralphium, between 89 and 104. Okay. All right. Some of these groups have numbers, and they have particular names also associated with them. And the group numbers go from 1 through 18, but the preferred way for this textbook and myself included is to go with these labels: the 1A, 2A, 3A, 4A, 5A, 6A, 7A, and A, 8A. So those A columns are the elements in those columns are the representative elements. So the A group elements are the representative elements. And then you have columns in the middle, and they are the B group elements, and they are the transition elements. And then, as I mentioned, some of these groups have characteristic names. So group 1A is given the name alkali metals. Group 2A is alkaline earth metals. Both the elements in both groups are extremely reactive metals. The group 1A, the alkali metals, being the most reactive among the metals, followed by group 2A, the alkaline earth metals. Now, some of the groups don't have any particular name associated with them. Among the non-metals, group 8A are the noble gases. These elements are extremely unreactive. They tend not to form compounds, and so all the other elements are trying to form compounds in order to achieve this kind of stability that the elements in group 8A have. Most of them are gases, most of them are monoatomic gases. And then you have group 7A, which are called as the halogens. Okay. And as I mentioned before, some of them have very characteristic colors associated with them. All right, we'll stop here and continue this in the next video.